Uh, Hello, guys. How are you doing? Uh, Good, great to hear that. So, I assume you have all completed the SQL setup I asked you to work on. So, I think everyone of you have managed to successfully install that. I have uploaded the setup post process in detail, so you can take help of that. Okay, then. I understand that it might not be perfect, but the steps are clear if you follow along visually, you can easily install it. Okay, the key is to watch carefully, pause the video at every step, and implement it as you go. It's crucial to understand what's happening in the process. Okay, so if you have any issues, you can go to the control panel and select the program and uninstall it. Then again install the program and it will fix your issue, hopefully. Okay. All right. Can someone explain what a database is in a simple term? So a database is like a warehouse, a massive storage place for all of our data. Now, if you think of this warehouse, imagine it has many rooms, shelves, and cupboards to organize the items. Similarly, a database contains tables and columns to organize the data. So, think of the database as a uh, think of the database as a building of strong materials. So, it is a database. Just like we don't rebuild a building every day, we don't often change the structure of a database. The structure includes tables and columns, which we generally don't alter frequently. So it has tables and columns. Now within the tables and columns, we store data. This data can be anything, numbers, text, etc. It's like putting books, balls, or clothes into shelves. Unlike the structure, the content within the tables changes frequently. Excuse me. So suppose it is a database, it is A, B, C, D, A, B, C, D, E. So what is this thing? It is called the database. Okay. And now there are tables and columns, like column A, B, C, D, E, etc. Then each of the these columns can contain various information like books, balls, numbers, etc. Okay, so the data are changeable and the columns are non-changeable. Okay, now we use SQL to manage database. SQL has different types of commands, each serving a specific purpose. So let's explore it. Um, wait, let me fix it. Okay, now let's explore it. So there are different types of SQL commands. Suppose one is DDL, another one is DML, then DQL, and the last one is DCL. So the DDL is the data definition language. The DML is the data manipulation language. DQL is the data query language, and the DCL is the data control language. So the purpose of DDL is it is used for creating and modifying the structure of the table. So it works on the object like the database, columns, tables, etc. It has several types of command like uh, create, drop, etc. So the create is to create new database tables or columns. The drop is to delete an object like a table or column. There is also alter to which can modify an object's structure. There are different subcommands like add, modify, rename, drop, etc. for adding, modifying, and renaming the table. There is also truncate to delete the data inside the table but keep the structure intact. Okay. Then there is the data manipulation language. Its purpose is to manage non-object data, which are the contents inside the tables and columns. It focuses on working with the data. So it has commands like insert, delete, update for inserting the data, for deleting the data, and updating the data. The third one is data query language. It is used to fetch data from the database. It retrieves data but doesn't modify it. It has commands like select, use, describe, etc. Select is useful to query and retrieve the specific data from a table. Use is used for switching between database. And describe is for to get the structure of a table. And at the last, the data control language is used to control access to the database. We will talk about that in the later part. Suppose we create a command called create table students in ID, name, variable character 50, age, integer. Okay. So now let me show you something. Let's create a database for students. Let's create a database for countries. So you can use the command create database if not exists. Then then create the table called rich countries, which has country ID, country name, region ID, then select rich countries. It will show us the table inside that database, which is country ID, country name, and region ID. Okay. Similarly, we can create a database for our school. Here, instead of the countries, we can write create a school database. Then our next task is to create a table within the database. So to create a table called student in the specific column, each column will have a specific purpose and types of data it will store, such as uh, ID, name, marks, etc. This column must be well defined and their data type must be the kind of data we expect them to hold. For example, in ID, it will held onto numeric values, so it will be integers. And name will store different types of characters like student's name, so it will have variable character. And last, we want to add marks. So it will be different numerical scores like grades or marks. Okay. So it will also be integer. So by creating table students, it will register a table in the database. Okay. Then let me show you create table students. Then ID integer not null. Name worker not null. Then marks integer. Here the create table students creates a new table named students. Then ID not integer not null means the ID defines the ID column to accept integer values and ensures that it cannot be left empty, which is not null. Okay. Then the name, which is varchar, is used to define the name of the characters uh, of the students, which can store up to 50 characters. And it also cannot be left empty. And at last, we wrote that the marks is integer. So this defines the marks column to accept integer values. Since we didn't specify not null, it's optional to fill in. Okay, so it can be also zero. Okay. So, as I've told you before, for the rich countries, uh, if you want to drop the table, delete the table, so you can write drop table space rich countries. And if you want to truncate it, so you can write truncate rich countries. You will have to give a space within between them. Okay. Now, we are going to use different types of data, alphabets and numbers for our database. For the variable characters, we will use worker, and for marks and varchar, and for marks and grade, we will use integer or and decimals. Okay, so we will begin by discussing the marks column. For the marks column, what are you going to use, the integer or the varchar? So for the marks, you will use varchar, sorry, integer. Okay, so let me draw a diagram. Here we have student no, which is student ID, then student name and marks. Okay, so the student ID can be 101, 102, etc. Then the name can be A, B, C, D, E, F, etc. Then the marks. Okay, so the numbers are usually integers and the names are usually varchars. So it symbolizes the characters such as A, B, C, D, E, etc. These are the characters of varchars. Okay. So for decimals, like marks can be 3.5, 3.33. They are decimals. So we will use integer in the marks column. Marks are numerical values like 50 or 100. So it's logical to store them as integers. For the marks column, we use integer because you then don't have alphabets for marks. For example, your total score is 100. You can have a name like RUL for a score. You must use a number such as 50 or 60. For grades, use decimal because grades are like CGPA or GPA and they have decimal points. So we have to use decimal to account for fraction values. In SQL, the decimal types stores numbers with fixed decimal places. If we define the column as decimal, like 42, that means the total number of digits is 4 with 2 digits after the decimal point. For instance, a value like 24.55 would be allowed. Now let's dive into deeper. The number 42 means there are 4 digits in total and 2 digits allowed after decimal. So it can be 111.11. Okay. So if I try to insert a value like 4.45, the first condition is met. But the second one might not be because the second condition requires exactly 2 digits after the decimal. Okay. So now let's move to the SQL query for creating the table. So we can create table by writing create table students, then write their ID in integer, then their names in varchar, marks in integer, and grade in decimal. Okay. So here Sn is a integer. S name is a variable character and marks is integer and grade is decimal. After creating a creating a table, we can use the function insert into to uh, insert the data into the table. So we can use the select command to view the inserted data like select star from student. This will retrieve all columns from the students table, okay? To see the structure of the table, we can use describe command, okay? So if you write describe students, it will show the information of the database. Now, if you want to delete all the rows from the table, you can use truncate command like truncate table students as I've showed earlier. So once we execute the truncate command, all data will be removed from the table. To confirm, we can run select command to see that if the data are there or not. Okay. So here you can see that after writing truncate, all the data I have inserted earlier was gone. Okay. Now earlier we inserted some data into the table. So let me push some data again. So here are the data 10125. Now, if you want to delete the non-null data into the columns like marks, grades, name, you can use the truncate command. If I use truncate and then select, then write run, Then run select star from students. Do you see that the data is gone? Okay. Now let's talk about changing the table name. A table is like an object, and if you want to rename it, you will have to use the command called alter table. So if you write alter table students rename to students info, its name will be renamed to student info. Okay. After renaming, if you try to run select star from students, you will get an error message because the table doesn't exist by that name. It now exists as student info. So you'll have to write select star from student info. So now you understand that when you rename a table, you must reference it by the new name. Now let's go back and change the label back to table name back to students to make it easier for us. You can do this by writing alter tables again. Now, let's talk about types. In student tables, we set the data type for the SN column to integer and the SNAME column to worker. What if you try to insert a value that doesn't respect the criteria? So if it will give an error. For instance, if I try to insert a value that is too long for the worker column or exceed the defined limit of the integer, it will fail. However, sometimes we need to make changes to the structure, like expanding the size of the column. So what command would we use to modify a column? We will use alternative. If you want to modify a column, let's say we need to change the size of the SN column from integer 5 to integer 6. We would use alter table students modify as an integer to 6. Even if you get a warning, as long as there is no error code, the modification will be executed. You can use described students to see the table structure. However, for integer, it won't show the exact number of digits. But if it's a varchar or decimal, the number of characters or digits will be displayed. So, if you want to change the name, change by inserting a value that exceeds the previous size, I will insert 101245. Okay, let me show you. Now, to modify the grade columns from decimal to varchar, you will need to write alter table students modify grade varchar. So after modifying the column, you can check again with the describe students to see the updated data type. This will show the columns as now varchar 6 instead of decimal. Okay. Now, if you want to write a comment which doesn't interfere with the code, you'll have to write two hyphens. This will make it a comment, not and won't count it as a code. Okay. Now let's talk about how to add a column to a table. Suppose you want to add a column named date of birth to table. First, we use the alter table command. To add a column, the syntax is alter table students at column, date of birth, space date. Now let's run this and see the results. You can see the column has been created. Whenever you use alter table, we get a warning message. Don't worry about the warning. It's not an error. You will notice this happens each time we have used alter. Now let's rename the column to something more appropriate like date of birth. To rename it, the syntax is alter table students rename column DOB to date of birth. Okay, you can see the column is now renamed. This is how you rename a column. Now let's move on. What if you want to delete a column? So if you want to delete a column, we use alter table again, followed by drop column. For example, alter table students drop column date of birth. Let's run this. So the column date of birth has been deleted. So remember, drop is used for deleting a column while truncate is used for deleting a table. Now let's move on to DML commands, starting with insert. The insert into command allows us to insert into a table. Let me show you an example. Suppose we want to insert a student's information into the students table. The command should look like this. Insert into students, then in bracket you will have to write student ID, name and age, and their values like 101, Johnny, 18, and null. Now you can see the data has been inserted successfully. Now let me show you how to insert multiple values in a single command. Here is the syntax. Insert into students, student ID, name, age. Then for values, you can write ID, name, uh, age, and after that, in another bracket, you can write the information of another student. Okay. You can see that multiple rows are inserted into one go. It's an efficient way to insert data when you have several records. Now let's talk about how update the existing records. Suppose we want to change the age of a student, ID 101219. The update command is used like this, like update students. Uh, Let me show you. So update students, then set age to 19 where student ID is 10. You can also update multiple columns at once. For example, let's change the name and the age of the student with student ID 102. So you will have to write update students, then set name John, age 21, where student ID is 102. As you can see, both of the columns are updated. Now let's move on to delete. If you want to delete a specific row, use the delete command. So if I want to delete here, for example, if you want to delete the students with the student ID 101, the command would be delete from a student where student ID equals 101. So the row has been deleted. You can also delete multiple rows at once. For example, if you want to delete all the students with an age greater than 20, the command will be like delete from students where age greater than 20. After running, you can see multiple rows were deleted based on the conditions. If you want to delete the entire table and all of its data, you can use truncate or drop. To delete all data but keep the structure of the table, use truncate table or students. To delete the entire table, including the structure, use the drop table student. Okay, so suppose here is serial number, then student name, then marks, then grade. Okay, so they all are part of students. So the delete and the truncate function are same. Okay, it deletes the row and the truncate function deletes the column. So so just to summarize the DDL commands, today we have learned create to create a table, alter to modify table by adding, renaming or dropping columns, drop to delete a table entirely, then truncate to delete all rows from table but keep the table itself. And for DML commands, we have learned insert to insert data, update to modify existing data, and delete to remove data from a table. Now, let me explain your tasks. You will need to practice these queries, and for your task, there will be two main files. You will use the doc file provided and practice each query 5 times, commenting out what the query does using the double hyphen method. And in task 2, you will create 6 tables like employees, department, etc. following the exact information given in the slides. So you will have to save your files as task1.sql and task2.sql and upload them into the assessment folder for after completing. You will create two separate files, one for task 1 and one for task 2. For task 1, you will practice the queries mentioned in the doc file, and for task 2, you will create the tables from the slides, ensuring the data follows the exact format. So, good luck with your tests, and if you have any question, you can ask me. So, so practice and do your task sincerely, and we will continue this topic into the next class. Till then, take care of yourself. Okay?